In example 10, we apply the sum to infinity formula of a geometric series as well as the skill of rationalization that all of you would have learned in secondary school in order to achieve the result required. Now we are given a geometric series as first term A and a common ratio of 1 over root 2. We are asked to show that the sum to infinity of the geometric progression is this. So to start off, we will write down sum to infinity is given by a over 1 minus r. So it will be 1 minus 1 over root 2 for the denominator. And we know that the denominator will simplify to a over root 2 subtract 1 over root 2 simplifying it further, we know that that will be a multiplied to root 2 over root 2 minus 1, and that gives us this. Now I will say that most of you will have no problem arriving at this step under examination condition. The challenge is it doesn't really look like what we want. Now if you compare what you have obtained so far with whatever that the question requires here in the highlighted part, you realize that the denominator root 2 minus 1 is not there, and therefore we have to think of a way to get rid of the denominator. So we apply the skill of rationalization, meaning we multiply by root 2 plus 1 to both the numerator and denominator. When we do this for the denominator, when we have root 2 minus 1 times root 2 plus 1, as a side note, let's write here root 2 minus 1. When we multiply to root 2 plus 1, it is actually akin to a minus b, a plus b, where a is root 2 and b is 1. And recall that is a squared minus b squared, and therefore is actually root 2 squared minus 1 squared. That is 2 minus 1, therefore is 1. So when we do that, in the denominator we'll end up with 2 minus 1. In the numerator, of course, root 2 multiplied to root 2 will give us 2, and we find that root 2 times 1 here will give us this root 2. Alright, so upon simplification we will get the result required in the question. That's the end of this example. Thank you.